Hi everybody, my name is Cameron and today we're going to be looking at motion, specifically the different types of graphs that you may encounter in your physics tests. So we're going to be looking at distance time graphs, acceleration, deceleration, velocity, time graphs. Okay, so with distance time graphs, we're going to have time on our x-axis and we're going to have distance on our y. Okay, so when we have something going in a straight line, escalating, okay, the object is going to be moving at a constant high velocity. Okay, so if it is straight line, it is a constant speed. Okay, now if it's a flat line, as we can see here, as time increases, our distance is going to be remaining the same. That means that the object is stationary. As we see in number 3, it is moving again, but at a slower velocity. How do we know it's slower? It's less slanted. Okay, it's not as steep as the first line. And then number 4, if it's this curved, almost exponential looking line, that means it's accelerating. Okay, the steepness or the gradient of the line is gradually increasing. That means it's accelerating. Okay, and you can calculate the distance at a point, or the velocity at a point, by going distance divided by time, x divided by y at a certain point. Okay, you could also work out the average by looking at the gradient of a line. Okay, so if you find the gradient of 1, that would be the velocity between those 2 points. Okay, so now we look at a velocity time graph. Velocity time graph is, you gotta kind of look at what's happening with the axes. Okay, so if we have our time increasing and our velocity increasing at a constant rate, that means that it is going to be accelerating. You see, our velocity is increasing. That means it's accelerating. Okay, now in number 2, when our velocity is remaining the same but time is increasing, it doesn't mean the object's not moving. It just means their speed isn't changing, or their velocity isn't changing. Okay, so they are still moving. They're just moving at a constant velocity, zero acceleration. Okay. Same thing though. When we have velocity time graph, the gradient is going to equal to acceleration. So the steeper the gradient, or the slower, or the, what do you say, more gentle the gradient, it's going to be accelerating a bit slower at number 3, but it's still accelerating. Okay. And number 4 would be deceleration. It is slowing down because it has a negative gradient. And over here, we just have different examples of other graphs that you may get. Okay, so something like with the velocity time graph, this would be our constant velocity. We would have one where it's accelerating, a constant velocity, and then deaccelerating. So have a look at these, familiarize yourselves with what you could be seeing in a graph, and it'll be easy marks. Okay, my name's Cameron, and I'll see you in the next lesson.